All right, so welcome to this video. Today we'll be looking at alpha and beta roots. Okay, so we'll be looking at how to find the exact values of, we are going to look at how to find the exact values of a combination of different types of roots. All right, so the question says, if A and beta are the roots of this quadratic equation here, find the exact values of all these combinations of the alpha and beta roots. Okay, so first of all, we know that if we're given a general quadratic formula like this is equals to 0, okay, then we know that the sum of the roots alpha plus beta is going to be given by the formula minus b divided by what? A. And then the product of the roots alpha multiplied by beta, this is just going to be c over a. All right, so the a is the coefficient of x squared. So in this case, that is 2. The b is the coefficient of x. So in this case, we are going to get a minus 5. And then c is the constant, which is what? 3. Okay, so let's start now finding the combination, the different combination that we have here. So on a, we have alpha plus beta. So alpha plus beta, this is the same as minus b divided by what? A. So this will be minus, and then the b is minus 5 divided by the a, which is 2. So this is just going to be 5 divided by what? 2. Okay, so alpha plus beta is 5 divided by 2. What about alpha multiplied by beta? Alpha multiplied by beta, this will be c over a. So this is just going to give me 3 over 2. So this is alpha multiplied by beta. Okay, so we can even write the answers there so that we can be remembering alpha multiplied by beta, that is 3 over 2. All right, so these were very simple because we have the formulas, okay? Okay, so the next thing now is to find what is the value of alpha squared plus beta squared. Okay, so the secret now is to always express any of these combinations that are left here, okay, in terms of the sum of the roots and the product of the roots. So what do we mean? Okay, we mean that we're going to change this expression here to have alpha plus beta and alpha multiplied by beta, because these ones here are the values that we can find direct. Okay, and we already have them. So once we express this in terms of alpha plus beta and alpha multiplied by beta, then we can just replace by the numbers. Okay, so now this one here is the most common identity. Okay, so x alpha squared plus beta squared. Okay, this here is the same as alpha plus beta, and then you say squared minus 2 alpha beta. So how does this come up? Okay, so I'm going to show you how you can derive this. So we derive this here by saying alpha plus beta and then squared. This here is the same as alpha plus beta multiplied by alpha plus beta. So alpha multiplied by alpha, I get alpha squared. Alpha multiplied by beta, I get plus alpha beta. Beta multiplied by alpha, okay, I'll get beta alpha, which is the same as alpha beta. And then beta multiplied by beta, I get beta squared. Okay, so now my mission here is to make alpha squared plus beta squared to be the what? To be the subject of the formula. And then these ones, I'm just going to add them. So I have 2 alpha beta. And then on the other side, that is alpha plus beta squared. So if you want to make this now the subject, you just move these guys to the other side. So it will be alpha squared plus beta squared is equals to alpha plus beta in brackets and then squared minus 2 alpha beta. Okay, so this is where this identity comes from. And it is the most common identity when you're talking about the alpha and the beta roots. Okay, so now to find alpha squared plus beta squared, we're just going to replace these guys with their values. So it will be, what is alpha plus beta? It is 5 over 2, and then squared minus 2 and then alpha multiplied by beta, that is 3 divided by 2. So this is going to give me a 25 divided by 4, because this square here goes to the 5 and goes to the 2. Okay, so minus, and then this is 2 multiplied by 3 divided by 2. So we can cancel out the 2's. So we're just going to remain with what? We're just going to remain with 3. Okay, we're just going to remain with 3. And then from here, we can find the common denominator, which will be 4. We can put this over 1. So that will be 4 there. 1 multiplied by 25, 25. Minus 4 there. That will be 1 into 4 is 4. 4 multiplied by 3, that will be 12. So on top, we have 25 minus 12, and then divided by 4. So that is going to give me, on top I have 13, down I have 4. So that is the value of alpha squared plus beta what? Squared. So we should write it there. So 13 over 4. Okay, we'll move on to the next one. The next one is very easy. We have alpha squared, beta squared. So you see that the power there is common. So I can factorize it to have alpha beta and then the squared outside. Okay, but I know the value of alpha beta. So that is 3 over 2 and then squared. So this will just give me 9 over what? 4. Okay, I get 9 over 4 here. The next one is 1 over alpha plus 1 over what? Beta. So we're going to combine this. So the common denominator here will be alpha multiplied by beta. So alpha into alpha beta, I get beta. So I have beta plus beta into alpha beta, I get alpha. And then the alpha multiplied by 1, I have my alpha. So this will simply mean that I have alpha plus beta, okay, because addition is commutative, okay, meaning that 5 plus 3 is going to give you the same as 3 plus 8, which is 3 plus 5, which is just 8, okay? So it doesn't matter the order in which you are adding them. All right, and then this will be divided by alpha beta. So this guy here, the alpha plus beta, what value did we find? Okay, we found 5 over 2. So I'll write 5 over 2, and then this divided by, I'll write it like this. Okay, so divided by, and then alpha multiplied by beta, that is 3 over 2. So this will just be 5 over 2. And then from grade 12, we said we can change this guy to a multiplication. So meaning this goes up, this comes down. So we have 2 over 3. Okay, so 2 there cancels with the 2 there. So I have 5 multiplied by 1 here, 5. 1 here multiplied by 3, 3. Okay, so that will be the value of 1 over alpha plus 1 over what? Beta. So that is 5 over 3. Okay, the next one we have beta over alpha plus alpha over what? Beta. So common denominator again here, it's just alpha beta. Alpha into alpha beta, we get beta. Beta multiplied by the beta, we get beta squared. Plus beta into alpha beta, we get alpha. Alpha multiplied by the alpha, we get alpha squared. So again, what I have on top there, it's commutative. So I can write it as alpha squared plus beta what? Squared. And then this I divide by alpha beta. Okay, so now we've already found the value of alpha squared plus beta squared in this question. This was this guy here, which was what? 13 over 4. Then I'm going to write this divided by like this. And then I write the value of alpha beta. So alpha beta was 3 over 2. Okay, so this would be 13 over 4 multiplied by, this now switches, so it will be 2 over 3. So 2 there, 1, 2 there, 2. So I have 13 multiplied by 1, I get 13, divided by 2 multiplied by 3, I get 6. So my answer is 13 over 6. Okay, so this guy here is simply 13 over 6. Okay, we continue. The other thing is that we have this guy here. So that is alpha squared beta plus alpha beta squared. Okay, so how can we express this as, or how can we express this in form of the sum of the roots, which is alpha plus beta, and the product of the roots, which is alpha beta? Okay, I'm just going to factorize what is common here. So here I have alpha and beta, even here I have alpha and beta. So I'll factorize alpha multiplied by beta. Then what I'll remain with in the brackets will be here, when I remove or I factorize alpha beta, I'm just going to remain with the alpha. Okay, and then I'll say plus. Here, when I factorize alpha beta, I'm just going to remain with what? With the beta. Okay, so now this is expressed in terms of the product of the roots and the sum of the roots. The product of the roots is 3/2. That one there. And then the sum of the roots is 5/2. So it means here I'm just going to get a 15/4. So that will be the answer there. So we're going to write 15/4 there. Okay. Right, so the next one is alpha to the power 4 plus beta to the power what? 4. Okay, so we need to express this, okay, in terms of, we need to express this in terms of the sum and the what? And the product. Okay, we need to express this in terms of the sum and the product. So how can we get the identity for this guy? Okay, so since this is to the power 4 to the power 4, okay, I'm going to say to get the identity of this guy, I'll say alpha squared plus beta squared, and then to the power 2 like this, which means I'm just going to have alpha squared plus beta squared multiplied by alpha squared plus beta what? Squared. That's what it means when I put this to the power 2. Okay, and then now I can expand whatever I have on my right. So alpha squared multiplied by alpha squared, that would be alpha to the power what? 4. Alpha squared multiplied by beta squared, that would be plus alpha squared beta squared. And then now I go to the beta squared multiplied by the alpha squared, I get another alpha squared beta squared. And then beta squared multiplied by beta squared, I get beta to the power what? 4. So meaning that I have alpha to the power 4 plus beta to the power 4 plus these two are the same. So we add them, we get 2 alpha squared beta squared. Okay, and then on the other part, I have alpha squared plus beta squared to the power what? 2. Right, so I want to make this guy here the subject of the formula. Okay, so I'm just going to take this guy, take it to the other side. So it will be alpha squared plus beta squared okay, is equals to, in fact, minus, because this guy counts the other side. So 2 alpha squared beta squared is equals to alpha to the power 4 plus beta to the power 4. Okay, so now I want to express this expression here, okay, completely in terms of alpha plus beta. Okay, so if you want, you can replace whatever you have inside there with its identity. So we said the identity for what we have inside there was what? It was the alpha plus beta squared minus 2 alpha what? Beta. So you can put this inside the brackets there for this identity there. But here we are lucky enough because we already have the value of this guy there, okay? So if you didn't have the value of this guy, then you would express it first like this, then you put in the numbers. But we already found the value of this alpha squared plus beta squared, which was this 13/4. So we can just use it directly, okay? So I'm just going to simply say alpha to the power 4 plus beta to the power 4 is the same as alpha squared plus beta squared, okay? And then minus 2 alpha squared beta what? Squared. Then I can just replace the numbers there now. Okay, so this will be equals to, the value of this guy is 13/4, then squared, minus 2. Then here, this part here, I'm going to write it as 2. And then I have alpha beta, and then the squared outside like that. Okay? All right. Or we can just simply add the value of this because we already have it, which is what? 9 over 4. So I'm just going to say 9 over 4. Okay, this is just going to be equals to 13, okay, squared, that is 169, divided by 4 squared, that is 16, minus 2 multiplied by 9, that will be 18, divided by what? 4. Okay, so the common denominator here will be equals to what? To 16. 16 there, I'll just get 1 multiplied by the 169, I get 169. And then I'll say minus 4 into 16. It's going to give me 4. And then that 4 multiplied by the 18 is going to give me minus 72. So this will just be equals to 169 minus 72. So that will give me 97, sorry. Okay, to give me 97 divided by 16. So that will be the answer. Okay, so the answer for alpha to the power 4 plus beta to the power 4 is simply 97 divided by what? 4. So the secret is always to turn whatever expression that you've been given of the roots in terms of its what? In terms of its summation and what? And the product. Okay. And in this case, we already had found the value of this and this, so it was easy. But if we didn't have, then we'll write this equation as I write the identity for this guy, which is alpha plus beta squared minus 2 alpha beta. Okay, so this whole thing here represents this, and then I square it minus 2. And then here I'm going to say alpha beta, and then I square. And then now I just replace individually the value of the sum there, the product there, the product there. I'll still get the same answer. All right, so the answer there is 97 divided by 97 divided by what? Why did I write 4 there? Okay, it was 97 divided by 16, right? Yeah, must be. So let me go back just. So it's 97 divided by 16 there. I don't know why I write 4. Okay, so that is divided by 16. Okay, we're done with this one. So now let's look at the other one. So the other one is alpha to the power 3 plus beta to the power 3. So we have to get an identity for this, okay? So if you want all those identities that I was writing down, you can just simply memorize them. And then when the question comes, you just answer it like that, okay? But if you don't want, then you should be driving them every time like I'm doing here. So to drive the expression for this guy, I'm going to say x plus beta, and then to the power what? Alpha plus beta to the power 3, because I can see power 3, power 3. So this will be equals to alpha plus beta, okay? And then alpha plus beta squared, right? Because this is power 3. So when I multiply this, I get back this. But I already have the identity for alpha plus beta squared. So the identity for this guy was what? Okay, the identity for this guy was, in fact, let's just expand. So we are going to say alpha multiplied by alpha, alpha squared, alpha multiplied by beta plus alpha beta. Now we go to the beta multiplied by the alpha. It will be alpha beta as well. And then beta multiplied by beta, I get beta squared. So this will be alpha plus beta. And then in the brackets, I'm going to have alpha squared plus beta squared, then plus, I combine these two, I have 2 alpha beta. Okay, so this is going to be equals to, we're just now going to multiply these two. So alpha will multiply with everything in here. So it will be alpha multiplied by alpha squared. It will be alpha to the power 3. Alpha multiplied by this, it will be plus alpha beta squared. Alpha multiplied by this, it will be plus 2 alpha squared beta. And then now we start with the beta. Beta multiplied by this, I get plus alpha squared beta. Beta multiplied by this, I get plus beta to the power 3. Beta multiplied by that, it will be plus 2 alpha beta what? Squared. Okay, and then there we just get the common terms together. So the ones with the power 3, we put them together. So that would be alpha to the power 3 plus beta to the power 3. Okay, and then here I have alpha beta squared. Even there I have 2 alpha beta squared. So I'll add them to get plus 3 alpha beta what squared. This is 2 alpha squared beta plus alpha squared beta. So that is plus 3 alpha squared what beta. Okay, and this whole thing is equals to alpha plus beta to the power what 3. All right, so now let's make alpha to the power 3 plus beta to the power 3. This is supposed to be 3. Let's make it the subject. Okay, so if we make it the subject, then this guy is just going to be equals to, okay? So we leave this guy alone this side, and then the rest go to the other side. So that will be alpha plus beta to the power 3, okay? Minus 3 alpha beta to the power 2 minus 3 alpha squared beta. So that will just be alpha plus beta to the power 3. And then what is common between these two terms here? Okay, we see that what is common is the minus 3 alpha beta. Then what do I remain with here when I remove the minus 3 alpha beta? I remain with the beta plus here I remain with the alpha. So this beta plus alpha, we know that it's the same as alpha plus what? Plus beta. Okay, so now we have our identity for alpha to the power 3 plus beta to the power what? 3. So now we're just going to put in the what? The values. So alpha plus beta, it's 5 divided by 2 to the power what? 3 minus 3 alpha beta, that is 3 divided by 2. Okay, and then alpha plus beta, that is 5 divided by 2. So this will just be, this 3 goes to the 5 and to the 2. So now 5 to the power 3, that is going to give me 125 divided by 2 to the power 3, that is going to give me 8. Okay, and then I have minus, so this will be 3 multiplied by 3 multiplied by 5. Okay, 3 multiplied by 3 multiplied by 5, I get 45 divided by, this 3 is the same as it's over 1, so this is 1 multiplied by 2 multiplied by 2. So that is going to give me what? 4. Okay, so the common denominator there will simply be 8. Okay, the common denominator there will be 8. So this will be 8 into 8, 1, multiplied by the 125, minus 4 into 8, that will be 2. So 2 multiplied by the 45, that will be what? That will be 90. Okay, so that will be 90. So I was saying minus 90 is equals to, so that will be 125 minus 90, that will just give me 35 divided by what? 8. Okay, so that is the value for alpha to the power 3 plus beta to the power 3. It's simply 35, okay, divided by 8. So this guy here, I'll just write it down here. It's 35 divided by 8. Okay, so now let's look at the last one on these questions here. So the last one is alpha minus beta. Okay, so how do we get the identity for alpha minus beta? Okay, so we get the identity again by just saying alpha minus beta, and then we say squared. So this will be the same as alpha minus beta, okay, multiplied by alpha minus beta. So I want to express this in terms of sum and the product of the roots. So meaning alpha plus beta and alpha multiplied by beta. So this will be equals to alpha multiplied by alpha, I get alpha squared. Alpha multiplied by this, I get minus alpha beta. And then this here, which is minus beta multiplied by alpha, get minus alpha beta. Minus beta multiplied by minus beta, I get plus beta squared. So this would be the same as alpha squared plus beta squared minus 2 alpha beta. Okay, but we know the identity for alpha squared minus beta squared. So this part here is actually the same as alpha plus beta squared minus 2 alpha beta. So this whole thing here is just the identity for this part. And then I have this another one which is minus 2 alpha beta. So this will just simply mean that I have alpha plus beta, then squared minus 4 alpha beta. So this whole thing here is equals to alpha minus beta to the power what? 2. Okay, so now I just want alpha minus beta. So what do you think I should do? I should just square root both sides. Okay, and I also square root both sides. So if I square root the other side, it will be plus or minus, and then here the 2 and the square root is going to cancel. So meaning that alpha minus beta is equals to plus or minus the square root of alpha plus beta squared minus 4 alpha beta. Okay, so let's now put in the numbers. So it will be equals to plus or minus the square root of alpha plus beta, that is 5 over 2, and then squared, minus 4. Alpha multiplied by beta, okay, it's 3 over 2. So it means we have plus or minus the root of, this will be 25 over 4, okay, minus, here I'll say 2 there, 1, 2 there, 1. I mean 2 here, this is 2. 2 into 4 is 2, and then there 1. So 2 multiplied by 3, I get 6 over 1. So I can combine this, okay? So that will be 25 over 4 minus 6 over 1 divided by what? 4. So meaning that 4 into this 4, that will just be 1. Then 1 multiplied by 25, 25 minus 6 into 4, 4. Multiplied by 6, 24. So this will just be equals to 1 over what? 4. So this will be equals to plus or minus the root of 1 over 4. So this will be the same as plus or minus, what is the root of 1? 1 divided by the root of 4, it's 2. So the answer there is plus or minus 1 over 2. All right, so we are done simplifying all these. Okay, so as you can see, the secret is always finding an expression that is in terms of the sum of the roots and the what? And the product of the roots. All right, so if you're enjoying this video, we have a lot more videos on our website. You can visit discretelearning.com. You're going to find a lot of videos on different math concepts. Okay, so let me just show you. So you can see this tutorial sheet here has 25 questions, and it covers a range of different topics. So express the following as rational numbers. Okay, you can see simplifying surds, rationalization, representing sets on number lines, solving rational equations. There's solving simultaneous equations using Cramer's rule. Cramer's rule, if you have a 3 by 3 matrix, this is what modulus equations. So we've solved all these questions here that you can see. Okay, so if you'd like to access the full videos, you're welcome. Just visit discretelearning.com. So I can even show you here before you continue. So you go to Chrome and then you type in discretelearning.com, and then you go to the website. Okay, so once you are in the website, this is something that you're going to see. So you can see there are courses there: mathematics, chemistry, physics, biology. You can register for any that you want. Okay, you can register for any that you want. Once you open this course, you go in the folder for general mathematics. Okay, so general mathematics, if you are from any other universities apart from these ones that are listed here. Okay, so for example, if you're from UNZA, CBU, Mukuba, Cavendish, any other university that you can't see here, you go in the general mathematics folder. Okay, then once you are here, you see topic lessons, summarized notes, tutorial sheets and assignments, past quiz, test, and exam papers. So if you go in topic lessons here, okay, you're going to see that you're going to find all the topics that you're going to be doing. Okay, so you can be learning using these videos that we have at your own free time, okay, anywhere, even in your what? Even in your blankets. So for example, if I pick a topic like, let's say I pick a topic, what? Logs and exponentials. If you go in logs and exponentials, you're going to find a lot of videos explaining all that you need to know about logs. Okay, how to solve their equations, how to graph their equations. Okay, all those videos are there here. You can learn at your own time, at your own pace. And also, apart from the topic lessons, we have we have the video, we have the tutorial sheets, I mean. So you go in the tutorial sheets, okay, you find the tutorial sheets solved. You go to the past quiz test papers, you find the what? The past papers solved. Okay, so if you'd like to register, just follow the link in the description here. It will give you the video registration guide, the link to our website, and the link to our mobile app. So on the mobile app, okay, you can actually download these videos and watch them what? Offline. Okay, without internet, you can download them and be watching them offline. Okay, so if you'd like to contact me, my number is 0779 96 40 10. You're going to find me to the pool solutions like that. All right, so now let's continue solving our questions. So back to business. We move to the next question, which is this one. Okay, same concept of what we've been doing, but we've been given a different quadratic equation now. So here they're saying the equation x squared minus 5x plus 6 is equals to 0 has the roots alpha and beta. Find the value of alpha plus 2 multiplied by beta plus 2, 1 over alpha plus 1 over what? Beta. Okay, so first of all, we have to get the alpha plus beta, which is minus b over a, and then alpha multiplied by beta, which is c over a. Okay, so what is what is the b? So here the a is 1, the b is the minus 5, and then the c is the 6. So this here will just be alpha plus beta is equals to minus, the b is the minus 5, divided by the a, which is 1. So this will just be what? 5. So alpha plus beta is giving me 5. What about alpha multiplied by beta? This will be c divided by a. So the c is the 6, the a is the 1. So this will just be 6. Okay, so alpha plus beta, we found it is 5. Alpha multiplied by beta, we found it is what? 6. Okay, that's all we need to answer the rest of the questions. So the first one, they're saying we find the exact value of alpha plus 2 and then beta plus 2. So what do? We expand. So alpha multiplied by beta, I get alpha beta. Alpha multiplied by 2, I get plus 2 alpha. 2 multiplied by beta, I get plus 2 beta. And then beta multiplied by beta, 2 multiplied by 2, I get 4. Okay, so this here will mean that I have alpha beta plus, here I can factorize the 2 to have alpha plus beta, and then plus what? 4. So it means my final answer here will just be, what is alpha multiplied by beta? 6 plus 2. Alpha plus beta is 5, and then plus 4. So this will just be equals to 6 plus 10 plus 4. So this will give me a 20. Okay, so that will be the value of alpha plus 2 multiplied by beta plus 2. The other one that we have, okay, we had this here even on the previous question, that is 1 over alpha plus 1 beta over a, 1 over beta. So the common denominator here will be alpha beta. This into this, I get beta. Plus this into this, I get alpha. Then we said whatever is on top there is commutative. So we can write it as alpha plus beta divided by alpha beta. So this will be equals to alpha plus beta is 5, alpha multiplied by beta is 6. So that is the answer there. Okay, that's the answer there. Okay, we move to part B. Part B, what is our A here? Our A from this quadratic equation is 3. Our B is minus 8. Then our C is equals to what? 4. So they're saying find the exact values of these expressions here. So first of all, we need to find the value of alpha plus beta, which is minus B over A. So minus 8 divided by A. So that will just be 8 over 3. So that is my alpha plus beta. Then alpha multiplied by beta, it will be C divided by A. All right, so those are the values there that we're going to be using. So now I get the first one, which is 2 alpha plus 1, and then 2 beta plus 1. Okay, I expand. So 2 alpha multiplied by 2 beta, I get 4 alpha beta. 2 alpha multiplied by 1, I get plus 2 alpha. And then 1 multiplied by 2 beta, I get plus 2 beta. Okay. The other one is 1 multiplied by 1, I still get 1. So here I'm just going to have 4 alpha beta plus, this guy here is 2, and then alpha plus beta in the brackets plus 1. So meaning that I have 4. What is my alpha multiplied by beta? It's 4 over 3. Plus 2 alpha plus beta, that is 8 over 3. And then plus 1. So this will just be equals to 4 multiplied by 4. That will be 16 over 3. Plus 2 multiplied by 8, again 16 over 3. And then plus 1. So 1, okay, to make the addition of the fractions easily, I'm going to write it as 3 over 3. It's the same. So we see that the common denominator there is just 3. And then I can just add whatever is on top. So that is 16 plus 16 plus 3. So that is going to give me a 35 divided by 3. Okay, so that is the value of the first guy there. It's just 35 over 3. What about the second one? Okay, so you can try it out. Okay, so you can pause the video, you try it to find, and then you compare to what I'm going to find. So here it will be alpha squared plus beta squared plus 2 alpha beta. This is equals to, we already know the identity for this guy here. Okay, the identity for that is simply alpha plus beta squared minus 2 alpha beta. Okay, and then we add what we have there, which is plus 2 alpha beta. So these guys are going to cancel out. So I just remain with alpha plus beta and then what? Squared. So alpha plus beta is 8 over 3. And then we square this, we're just going to get 64 over 9. Okay, so that's the answer there. Okay. All right, so we're done with this video. Thank you so much for watching. This has been Tutor Post Solutions, always there for you.